Hi everyone. This is the second part of reviewing for test 1. I start by this question. We are looking for a domain of function. F of x is a square root of 3x minus 15. This function contains square root. So this is the second root. We have even root of a function. We know that under the even root, we cannot put anything. Input here should be positive or at least 0 because even root of negative values, it's undefined for a real number. I mean that, for example, second root of -4, it doesn't have any meaning when we are speaking about real number, and definitely it has meaning when we are speaking about the complex set. Okay, now we are speaking about the real number, so this doesn't have any meaning, it's undefined. When we have even root, whatever is inside should be at least 0. So to find the domain, which means that all possible input for a function or all x values that makes function defined, 3x minus 15 should be at least 0. Now we have an inequality to solve. The first step is to add 15 to both sides of this inequality. Then we have 3x greater than or equals to positive 15. The next step is to divide by the coefficient of x. Here is positive 3. And we get x greater than or equals to 5. So domain of function is all x values greater than or equals to 5. If I want to show it in the number line, x can be 5 and whatever is greater than 5, it means at the right hand side of 5. In terms of interval, I can say that domain is from 5 to positive infinity and also includes number 5, so we use square bracket for 5. Now let's continue by the next question. F of x is square root of 2x and g is 2x minus 5. So the first question is, what is domain of f and domain of g? As you see, f consists square root. We know that whatever is inside the square root or even root should be at least 0. So to find the domain, 2x should be at least 0. Now divide both sides by 2. You get x greater than or equals to 0. This is the domain of function f. How about function g? Is 2x minus 5. We know that 2x minus 5 is a linear function and domain is all real number. You may want to show it as negative infinity to positive infinity interval. Now, what is f plus g of x. Definition of addition or subtraction is addition of functions or subtraction of functions. F plus g of x is f of x plus g of x. So what is f? It's square root of 2x, and then you replace g, and if it's possible, you simplify. Here we don't have similar terms, so we cannot simplify it more. Now, if I ask you what is f plus g at 10, you simply substitute 10. The answer is 2 times 10 plus 2 times 10 minus 5, and then you simplify. It's the square root of 20 plus 15. Now, what is domain of f plus g function? Domain of f plus g is intersection between these two domains. Intersection of these two domains. So what is the intersection? Let me show you. Consider the number line. Domain of f, it's from 0 to positive infinity. This is the domain of f. And domain of g, it's all real number. So it's from negative to positive infinity. Now, what is the intersection between these two? It's from 0 to positive infinity, this part, right? So domain of f plus g is also 0 to positive infinity. It's like domain of f. Intersection of these two, which is x greater than or equals to 0. Now, how about FOG of x? How we can find FOG? FOG is f of g of x. F of g of x. It means that look at the function f. Previously input was x. Right now input is function g. What is function f? It's square root of 2x, but instead of x, right now input is g of x. So it's square root of 2 times g of x. And what is g? It's 2x minus 5. So if I simplify, it's equals to 2 times 2x, which is 4x, and 2 times negative 5, which is negative 10. Now, what do you think about domain of FOG of x? Do you think it's intersection between domain of f and domain of g? Or maybe I should look at FOG itself and find the domain of function. When we want to find the domain of function, actually we check what can be an input. Input for function FOG first comes from x here. x is input of function g. Previously, we know that x can be anything, any real number. So here can be anything. Then what is the answer? What is the value of function g? When you put some x here, then you multiply it by 2, then subtract 5. Again, it can be any real number. So here, any real number. Can I put any real number inside the function f here? No, we cannot put anything inside function f because it's even root, and even root, whatever it's inside should be at least 0. So whatever it's inside here should be at least 0. But here x should be at least 0. Now instead of x, you want to put 2x minus 5. So 2x minus 5 at least should be 0, right? So to find the domain, here 2x minus 5 at least should be 0. It means that 2x should be greater than 5 and x should be greater than or equals to 5/2 or 2.5. You see that domain, it's not x greater than 0, and it's not intersection of domain of f and g. For the next question, we have the statement of a function. F of s is 4s plus 7 divided by s minus a. And we know that f of negative 3 is positive 1. It means that if the input is negative 3, input here is s. So if s is negative 3, then output is 1. And we are looking for value of a. Actually, we have one equation. F of negative 3 is 1. It means that if s is negative 3, then 4 times negative 3 plus 7 divided by negative 3 minus a is positive 1. Now we have an equation to solve. Numerator is 4 times negative 3, negative 12 plus 7. Denominator, negative 3 minus a is 1. Numerator is negative 5. Denominator, negative 3 minus a is 1. Negative 5 divided by negative 3 minus a is 1. It means that negative 5, it's equals to denominator, right? 7 divided by 7 is 1. A divided by a is 1, right? So when we divide two things and the answer is 1, it means that numerator and denominator are equals to each other. So negative 5, it's equals to negative 3 minus a. I'm looking for a. So let's add positive 3 to both sides. Negative 5 plus 3 is negative 2. And negative 3 minus a plus 3 is just negative a. And now multiply both sides by negative 1. A is positive 2. Consider the graph of this function. What we know about this function? What do you know about domain? About range? What is the maximum value? What is the minimum value? What is the absolute maximum or absolute maxima? What is the local max? What is the absolute minimum or local minimum? Do you think this graph is increasing or decreasing? Let's start by domain of function. Domain of function, it's all x values for that function. So we look at the x-axis. What is the first point? The starting point is here, -7, -8. What is the x value? -7. And then the graph is continuous. It means that it contains all x values from here to here, which is the end point. What is the x value here? Is 6. So domain is from -7 to +6. All points in this interval from -7 to +6. -7 and +6 both are included as well because we have these 2 points. And our function is continuous, so we have continuous interval. What is range? Range means all y values. So we look at the y-axis. But we do not look at the first starting point and end points. We look at the lowest and highest y value. What is the lowest one? -8. What is the highest one? +12. And again, our function is continuous. So range is from -8 to +12. Now, what is the maximum and what is the minimum? Maximum is the point with highest y value. When we say absolute maximum or global maximum, it means look at all different points on the function, on domain of function. It means that from here to here, I'm looking at all different points. Which point has the largest y value among the entire domain? Here I see a peak. Y is 12. And again, here there is another peak. Y is 8. Between these two, 12 is the largest. So the maximum, global maximum, absolute maximum happens at point -3 and +12. What is the value of absolute maximum? The value is positive 12. What is the point? Is negative 3 and 12. What is the local maximum? What's the difference between local and absolute or global? Local means the point that has greatest y value in the some part of the graph. In some part of the graph. For example, here in this part, this point is a local maximum. So 6 and 8 is 1 point for local maximum. What's the absolute minimum? Absolute minimum means that the point with lowest y value in the entire domain. So in the entire domain of function, which point has the lowest y value? You see that the lowest happens at negative 8, and we have 2 points, negative 7 and negative 8, 2 and negative 8. So there are 2 absolute minimum. So what do you think? Which point is the local minimum for this function? So local minimum, when we look at the graph of function, means a point with lowest y value in some section. For example, if I consider this part, this is a local minimum again, 2 and negative 8. We see that a local minimum, and again we see that point as a absolute minimum. Now the question is, any absolute, for example, minimum can be a local minimum and vice versa? The answer is no. All absolute maximum, like absolute max or absolute mean, can be local as well. Here I can put negative 3 and 12 and consider it as local max as well. Yes, it's possible. But the opposite is not true. It means that not any local max can be absolute, or any local mean can be absolute. But any absolute can be also a local. Is there any other local minimum? By looking at the graph here, you see that in this part, for example, negative 7 and negative 8 is a local minimum. If I consider, for example, this part, then this point also can be a local. But the best and most obvious, it's here and here, and because they have the lowest y value, I have to consider them as absolute minimum as well. Okay, now what we know about the graph of the function? Do you think it is increasing or decreasing? When we want to check if a function is increasing or decreasing, always look at the function in the positive direction of x. So I check the function from here to here. And now let's move on the graph of function. It goes up, it means it is increasing. But then you see it goes down and it's decreasing. And again, it goes up. So always keep moving in the positive direction of x and see if it is increasing, goes up, or if it's decreasing, goes down. Now, this function is not increasing or decreasing. The function actually is increasing in this interval between this point and this point, and also between this point and this point. So in the interval when x is from -7 to -3, and also from +2 to +6. And the function is decreasing in this interval, x between -3 and +2. And I think it's better to just put open interval, because at -3 or +2 or +6 or -7, I don't want to consider all these points in the increasing or decreasing part. So we know that from here to here it's increasing, here to here is decreasing, and here to here is increasing. Can I say that this function is even or odd? No, this function, it's not even, and also it's not odd. If the function was even, I expected to have a function symmetric respect to y-axis. It means that, for example, if there is this part, my expectation is to see something like that. Or if it's odd, then I wanted to see the symmetry respect to the origin. For example, if there is this point on the graph, then my expectation is to see such a point. Or if there is this point on the graph, my expectation is to see this point on the graph of function to say it is odd. But this function, it's not even, and also it's not odd. Okay, this is the second part of the reviewing for test 1. I continue in the next video reviewing for test 1. See you in the next video.